So good evening. Welcome to the Symantec breakout session. I appreciate everybody showing up. I think middle of the week, 5:30 in the afternoon, for those of you who are here in person, is pretty rough. I know it's a pretty intense week. There's a lot of stuff going on. So we can help weed out the room a little bit. Any competitors here of Symantec? You compete with us? Okay, you can stay. So what I'd like to do, keep in mind that the slides will be available on SlideShare after the talk, so you don't have to worry so much at this point in the day about taking notes, as well as the video of the talk will be available on YouTube within the next few days. I would also invite you to visit the Symantec booth, where you can learn a lot more than we have time to cover in a breakout session about what Symantec's up to. And I thought to kick us off, I would share a little bit of context about who Symantec is these days, especially as it relates to cloud, and some of the themes you'll see in the booth to kind of set the stage for some of the more technical, in-depth topics we're going to describe. So if you visit a booth, you'll see mention of the cloud generation. So focus on security for the cloud generation. In order to deliver that, we've built a platform we describe as the Integrated Cyber Defense Platform, or ICD. I'll apologize in advance. Much like every company, we're full of acronyms, so if I sound like acronym soup, I'll try to slow down a little bit. You can throw something at me. So the ICD platform and cloud generation. So to sort of explain cloud generation, I think about the CISO meetings that I've been in over the years as part of Symantec. There's been thousands of CISOs that I've met. And there's some key differences in those conversations that happened maybe even just 5 years ago and how they go now. So 5, 7 years or so ago, the average CISO conversation about security and cloud went a little like this. My CIO would like to realize the cost benefits of moving to the cloud, so please make sure that we can secure that information so that we can do it. It's kind of a permission idea, this idea that we would wait to move to the cloud until security was ready. So you fast forward 5 years or so to today, and I can tell you those CISO conversations are completely turned the other way around. So that the reality of a security team these days are not faced with how do we secure it so we can do it. It's more like, well, we did it, or we're in the middle of it. How do we make sure that we finish strong? How do we make sure that we're building security into it as we go? And the pressure on them is not just coming from a CIO perspective, although it usually starts in terms of realizing cost savings. But it's also about agility, right? The promise of the cloud as a competitive advantage. The board of directors of these organizations are mandating sort of 3-year projects to get to cloud as fast as possible, and it's a business requirement now, not just a cost savings requirement. So if you think from a CISO standpoint, their challenge is pretty significant given the rate of change and the rate of cloud adoption that we see relative to the advancements in the security field. So whereas in the past, the security strategy might have been built around this idea that you have well-managed networks and data centers and endpoints, the security strategy of today needs to count for ubiquitous access to your data anywhere at all times. So what's interesting too in that context about those CISO conversations years ago is that customers often thought of things like mobility and cloud as different things. They were looking at security problems of iPad, tablet-type devices versus moving to a public cloud vendor. And I think what they see today is it's really all the same aspect of the same thing. In that, what's the value of cloud if you can't connect to it from anything? What's the value of a device if you can't deliver on that promise of ubiquitous access anywhere from any device? You need both. So the security challenge becomes not a point product type solution where you're going to buy Symantec Cloud Security 1.2. And that's better than 1.0, and you'll sort of integrate on there, and the cloud security problem is solved. What it means now is this is an ecosystem problem. So it's not a point product problem, it's an ecosystem problem. So we've put together a platform, and you can hear more about this in the booth, the ICD platform, that focuses on delivering security at a cloud ecosystem level. So you have to secure the endpoints, you have to secure the networks that connect those endpoints to cloud, you have to secure cloud applications from a SaaS perspective, and you have to secure messaging. And security means that you're able to provide core functionality across all those control points in terms of threat prevention. So anti-malware, for example, threat detection, incident response, all those kinds of ideas. Information protection, so understanding what is the content and context of the data that your applications and users are moving around this ecosystem. And then ultimately, how do you govern it in such a way that allows you to comply with increasingly complex regulatory landscape, right? GDPR might be a good example of how cloud makes that a little complex. So we're focused on the cloud generation, meaning the first generation of people who live and work in this new IT reality. And we're focusing on delivering security for that generation through an ecosystem approach, through an integrated platform that you see up on the screen. I think another key aspect of cloud is that people are looking for cloud-oriented solutions for agility, but also to abstract the complexity of infrastructure from the actual use of data. So around the technology platform, we also have a set of services. The services are meant to really focus more on outcomes than the hows, and than the technology components that make it true. So we have a set of services, for example, that use Symantec products to ultimately deliver automated detection and response capabilities powered by our global team of security analysts. So that's Symantec. I invite you to visit the booth and learn more about it. We work with a number of third parties on the platform and integrate a number of different technologies that are not Symantec into it. And obviously, we also partner with all of the global cloud providers to make sure that we're delivering a solution at Symantec scale with global reach. And obviously, this being reInvent, I'd like to talk now more specifically about AWS and what kinds of things we've been focused on with AWS. Promised that was the end of the high level. We're going to get much more technical as this goes. I see some of you have fallen asleep. So here's what we're going to talk you through. So I'm going to take you through a couple of aspects of our SOC technology platform. So for those of you not in the security industry, SOC is Security Operations Center. So this is the sort of hub of where our threat detection and response operations live. Then I'm going to turn it over to some of my colleagues who are going to talk about specific customer conversations that they're having and how that's influenced how they build and deliver products, including a conversation with our team from the LifeLock organization about some of the test cases that they've been looking at on how you would use AWS with some Symantec products to deliver interesting security outcomes. So that's what we're going to take you through. So who am I? So my name is Clint Sand. I lead product for our services business unit. The services business unit main focus is around a SOC technology platform that I mentioned, whose goal is to make sure that we build, deliver, and operate a platform that allows humans, our security analysts, to defend the customer environments. I think a lot of folks, when they think of a SOC or security operations, they tend to either think of automation, so the idea of orchestration, how can we just remove the human element from it? Or they sort of imagine a bunch of people sitting around monitors staring at log lines as they fly across the screen, right? This is a sort of security information and event management or SIM type approach where you'd actually have people looking at log lines as they come in, trying to find a needle in the haystack or to separate the signal from the noise. We see it as a sort of hybrid approach where a lot of automation is needed, but ultimately the human IQ is still fundamental to get the outcome that our customers are paying us for. So at a super high level, before I get much deeper into the AWS specific parts of this is kind of how the platform works. So the first thing you might imagine is we have to ingest data. We have to ingest a lot of data across a large and diverse set of sources. So we have a proprietary log collection platform, or LCP, because I'm sure I will say that a lot. We'll define that straight up front. The LCP sits in the customer's environment, and it can either act as a pull or a push. So you can sort of forward your Splunk logs, for example, directly at the LCP to get it into our system. Or it could go the other direction. So through APIs or JDBC drivers, for example, we actually reach out and go find or get the information that is most security relevant. LCP delivers those inputs in our log ingestion pipeline to our analytics engine, where ultimately we're automating the entire process of separating that signal from noise. So that the role of the SOC analyst, which is the third leg of the stool, shifts from find the threat, right? Threat hunting, look through all the logs, shifts from that sort of approach to a threat or detection interpretation. So now, instead of an analyst team having to manually use a SIM product to sort of figure out what they need to do, the system automates that entire process, and the SOC analyst or human element is now focused then on interpreting, prioritizing, validating, and ultimately stopping the threat. Right? So technology makes that happen. These are the sort of Lego blocks in our system at a high level. So this is true. This is how it works regardless of cloud or on-prem, quite frankly. Any sort of ingestion into the system kind of follows the same path. Specific to cloud, specific to AWS, here's how we've extended those capabilities to be cloud native. So the first thing we run into is customers who at least want to start with, look, whatever security devices I've got on-prem, I'm going to move them to the cloud. It's a lift and shift security model, and they at least start there. So the first element is making sure that we can very easily onboard and support security devices that they may be using on-prem in their EC2 environment. So not only do we extend support, but we also built an AMI, obviously, for our LCP appliance that you can get straight out of the marketplace. So when a customer onboards into the system, they can spin up an LCP in their cloud environment and automatically then support the hundreds of security devices that we already support on-prem, but in a cloud form factor. Second thing we did was we built a series of collectors for both Symantec and third-party security SaaS offerings. So one of the things we would see in a cloud migration model is that while people lift and shift a lot of their capabilities, they also look to leverage the SaaS version of whatever the on-prem product might be. So eliminate the things that they end up actually having to move. So we wanted to make sure that we support all of the different SaaS-based offerings, regardless of what cloud platform they're hosted in, and do that natively. The next thing we did was we built an integration with our CASB solution. So CASB is Cloud Security Access Broker, or Cloud Access Security Broker. This is technology we actually got through our acquisition of Blue Coat, which really sort of rounded out our capabilities. If you think about Symantec, you might typically, historically, at least think about endpoints, computers, securing endpoints. Blue Coat brought in a strong network capability as well as this CASB offering. The CASB offering is interesting for cloud as well as for how we consume the alerts, in that it allows us to go far beyond what you could normally detect in a log. CASB offerings, for example, can detect shadow IT use. So this idea that you've got users in the environment and they're using Box or Dropbox or whatever kinds of cloud services that maybe is against policy. We can consume all that kind of information into our managed security service through that integration. And then finally, but perhaps most important, we built cloud native collector capabilities for AWS platform. So this actually works kind of in two different ways. So one is a consumer of AWS alerts, so things detected already by AWS security services. So here you can think of things like Guard Duty or CloudWatch, as well as the collection of sort of raw data. You could think of VPC flow logs or CloudTrail logs, where we're consuming raw data about what's going on in the cloud environment so that our analytics can add a layer of detection beyond what you can get from your own security devices or what Amazon provides. So in doing this for a while, we've been in the top right of the Gartner quadrant for about 14 years with this offering. With the cloud adoption and the expansion of our capabilities into a sort of full managed cloud defense kind of model, what you can immediately then see is there's a scale problem brewing, right? So we're actually projecting that the amount of data that we'll ingest into AWS is over doubling year on year. So right now we're at about 200 billion events per day that we ingest. And I think what's most interesting about that is not actually the volume of ingestion. I think if you've attended the sessions this week, you'll know that ingesting 200 billion log lines and putting them into an S3 bucket, not that complicated. until your credit card runs out. Anybody can sort of put large volumes of data into an S3 bucket and call it big data, right? I think what's interesting about it is the connection between scale and security. So there's a well-known breach that's been in the media. It's a global shipping company. And what was said there is that the time between the malware infecting the first machine and the global operation being stopped was 7 seconds. 7 seconds. So when I think about cloud and I think about scale and I tie that into security, latency in the system is a security issue. We're essentially in a race condition with attackers. Can we find them and stop them before they can actually have impact to the organization, knowing that it can now happen in seconds? So, scale in AWS, latency in big complicated systems like this, it's not just about operational efficiency or improving the customer experience with the platform. It's actually a security issue. So when we thought about this, we said, okay, a lift and shift approach has some benefit. I mean, we can move our platform into AWS and sort of turn on auto scale, and we would see some benefits from that for sure. But with that added security dimension, it's not good enough. So we decided at the end of the day that in addition to adopting AWS as our sort of backbone in general for this offering, that we needed to roll up our sleeves and do the hard work of completely re-platforming some of the components of the system to use the AWS serverless components. And we chose the serverless component stack not just because of sort of the ease of adopting AWS to provide better security outcomes, but also then because our engineering teams can reallocate their efforts away from managing servers and more on the analytics side, which is ultimately what the customers pay us for. So the serverless concept is critical for us to realize the security benefits of the scale focus as we did this work. So I'm going to talk you through some of the things we did there. So this is a 300-level session, so I will assume you know what S3 is and how great it is and all that sort of thing. So obviously S3 becomes our storage environment. It provides a durable and scalable approach with things like auto scale, as well as being able to age data off automatically into Glacier at certain points and all that. So as I'm sure you would imagine, we're using S3 and replacing our storage arrays. And I can remember, and some of the guys in the room here on our team remember this very well. The idea before is you had to predict what your storage needs were going to be, place an order with a vendor, wait for the array to arrive, get it racked and all that kind of jazz, and then hope that you got it right in terms of predicting the data load you were going to need. And then if you see the prior slide where we're over doubling the amount of data and it's turning into an exponential curve, you would essentially end up in this continuous buying of storage arrays, and there are limitations to the walls of the data center, right? So S3 has been a great change. I think what's more interesting about it than just the fact we use S3 in this SOC technology platform is some of the stuff we do around it to ultimately feed the analytics pipeline in a way that reduces that latency I talked about as being a security issue. So our LCP appliance, when it sends data up into our system, there's sort of 3 levers that it waits for. There's either a number of rows or log lines queuing up, there's the file size of the log file queuing up, or there's the amount of time gone by. And once it hits the maximum threshold in one of those dimensions, wraps up the file and sends it up into the system. When it lands in S3, we fire Lambda functions, and the Lambda functions do a couple things. One thing they do is they buffer the incoming files. They wait for it to hit an optimal size that we know the downstream services like Redshift work best with, and then they write out a new file in Parquet format. And I'll get to it on the next slide, why Parquet and why that is such an important decision. The second thing those Lambda fires do is they create an entry in DynamoDB about metadata, about what the log source is, where it's coming from, those sorts of things. And that becomes important when we look at downstream consumption, again, of things like Redshift and Athena, which I'll describe a little bit more in the next slide. So if you think about scale again, and what's actually happening here at this level of ingestion, On average, we've got about 400 lambdas firing every second. So I mean, that's a significant technology advantage that the AWS platform is able to provide something that can work in that way. So 400 a second, it's about 35 million a day. It actually peaks at around 100 million lambdas firing every day, just to support this concept of full-scale global log ingestion across a potentially unlimited number of sources in a way that minimizes latency for security benefit, right? That's a massive achievement. The other thing that happens here is it's really our fan-out mechanism. So once the data arrives as an entry in DynamoDB that describes the metadata about what was uploaded, we essentially then fan out to downstream consumers. Typically, these are analytics processes. So in the case of streaming analytics, which usually drives a lot of the machine learning components of our system, things like Apache Storm and Spark maintain pointers in a Kinesis data stream. So that's how the analytic systems are able to consume directly from what gets put in S3s for sort of real-time, more of the advanced analytical use cases. For batch analytics, so these are security analytics that happen at some interval or when some condition is true. Typically, the batch analytics will leverage the DynamoDB directly to understand what's being put into the system and decide if it's time for them to act. Another way that we fan out the data is through SNS. So we're using SNS to enable downstream applications in EC2 to subscribe to specific topics. So when they get a notification of that topic, they can then take action. Probably the most interesting application in EC2 that uses the SNS topics is our log anonymizer. So if you think about one of the main values of Symantec doing this, the fact that we have the SOC technology platform, the services, and the technologies, is we're able to take customer log data, remove the customer-specific information from it, and then combine it upstream with product telemetry and security intelligence in that ICD platform for R&D purposes. So the ability to invent or design new types of security analytics to find these advanced attack actors becomes exponentially easier and more effective the richer the set of data that you have. So the anonymization of the customer data in our MSS service, for example, allows us to do some innovative R&D. And then finally, on the serverless component side, you've got this idea for access, query, and search capabilities. We're using a combination of Athena, Redshift, and Redshift Spectrum, depending on the different use cases, which obviously, from a scale perspective, gives us the idea with Redshift especially that you can scale up and down your search capability as the query loads change. So I asked the team, this is as fast as I can do it. I asked the team, with that work being done, what are the basic ABCs that anyone attending the session should walk out with, right? What are the sort of things that, if we would have been clear on at the start of this, would have made it easier or better, so that we could share that with you to avoid similar mistakes or help you onboard into a similar approach. So the first one is around that Parquet file format. So this is the idea that file types matter a lot in these kind of workloads where 7 seconds is a big deal from a security perspective. So for us, we chose Parquet because the combination of Parquet and Redshift allows us to realize the benefits of a columnar type of database structure. So if we looked at the queries in our system and said, a good chunk of the queries that are important benefit from columnar type of approaches, right? So for example, how many times have we ever seen this IP? That's a type of thing where you don't need to go every row to look for that IP and condition. You should just be able to do that in the column. So in our testing, using Parquet specifically as a file format with Redshift gives the best results. So the recommendation here is to really understand the query load that you have from your users and your applications, evaluate the different file formats that are out there, and test to make sure that the right combination of consumer of your data and how you're writing it to disk in a particular format gives you the right results. The second one is this idea of scale through creating one big system or many small systems. So I think there's a tendency when you think of big data systems to think of one big one. You create this big data pond, and then it continues to grow, and it continues to grow, and you scale by growing that one thing. Whereas that there are some use cases where it's actually better to make many, many small things. So in our example, Redshift Spectrum, for example, has a 15 limit on concurrent queries. So our system sort of runs normally at about 50 to 75 concurrent queries. So a limit of 15 is not going to fly. So rather than build one big Redshift cluster with that limitation, we worked directly with Amazon, pretty good partnership and great work with the AWS team to implement a system where we use many small Redshift clusters behind a load balancer. And that way we're able to get around that concurrency limitation. So that's the second recommendation is, don't think about scale in terms of making one huge thing, but sometimes it's better to make many small things. And then finally, there's a notion of flexibility. So in a legacy system, if we had a downstream consumer of data, an analytic engine, for example, that expected data in a certain way, we would rewrite the data. We would copy it. And in some cases, we're copying the same data 4 or 5 times in the data center for different use cases. Obviously, that's expensive in terms of storage, but it also increases latency, right? Which we said was the problem from a security standpoint. So by using metadata about our logs into DynamoDB, we can leverage things like AWS Glue and the Glue catalog concept, such that services like Athena and Redshift know how to use that data without having to rewrite it. So whether they need to see it by customer or by date or time or whatever, that metadata exists in the Glue catalog, and the services can use them directly. So obviously there's a lot of cost and efficiency for us in approaching it that way. So that ends the kind of first topic around scale and the importance of scale and some of the things that we've been up to as it relates to using the AWS serverless components. I certainly didn't do all that. There's a large team of people. So I know our VP of engineering couldn't be here this week, so I would like to thank him. So this is Matthew Barnes, and his engineering team did a lot of really good work to realize the benefits that we have in new platform by partnering with AWS. So a lot of interesting stuff there. So I'd like to move to our second topic, which is really more around, now that we're there, now that we've been doing this for so long, and we sort of see a different kind of rhythm and what's interesting from a security perspective in cloud as compares to other form factors. So on an on-prem environment, infrastructure change is an anomaly that's interesting from a security standpoint. You might expect a sort of baseline of these are your servers outside of change control process. If 10 new servers spun up in a data center and then started talking to an IP that they hadn't talked to before, that would certainly be a catalyst from a behavioral anomaly standpoint to investigate. That could be a security issue. You would not expect that. In a cloud environment, though, you would. Now, I think most of the customers that we talk to are sort of far away from realizing an infrastructure as code kind of approach where they're using a DevOps kind of process for infrastructure. But if you go to the expo and you were to take a shot of tequila every time you saw the word DevOps, you would not last very long. So please don't do that, because we need you in the sessions. But the point I'm trying to make is that the promise of infrastructure as code and the focus on getting there is so strong that we will have to think about security in that context, if not already. So what you see in the cloud environment is infrastructure is dynamic. It would actually make sense if there were 10 new servers that spun up and then you never saw them again. So as a catalyst for behavioral anomaly, infrastructure change is perhaps less important from a security standpoint. What becomes more interesting in cloud is actually user account access, a user account change, right? Since everything that happens within a cloud infrastructure happens under the context of a user account. So, obviously with this ICD platform we have, this is Symantec's core business, so we invest a lot of time, money, resources into building analytical systems, machine learning, algorithms and such to find these kinds of things. But, I asked for reInvent, I asked a couple of the researchers on my team, so Stan Kiefer and Brian Varner, how would a normal organization do this? Is there, much like the infrastructure that we looked at, the AWS serverless components, to make it easier on us, how would your average customer use these serverless components to detect these kinds of new ripples or new behavioral anomalies for user accounts? So here's what they came up with. So the first thing, I'll just build this out for you in the interest of time. First thing we did was we established a sort of new baseline process around identity and access management. So we suck out a customer's CloudTrail logs. We have Cloud Watch rules, which essentially filter out anything that's not a user action. We fire a Lambda function, which parses that data and then stores it in a DynamoDB instance. So it's storing what's the role, what's the user, what action did that user take, and then sort of metadata around the frequency and amount of times that this happens. So this establishes a sort of ongoing baseline. You know, DynamoDB is saying this is what's normal in my environment. So then we work with the guard duty team, such that when guard duty finds this particular event, they call it an unknown ASN caller. It's basically a type of security detection that says this user account is accessing the system from a network or IP that it has not before or doesn't normally. So we use the guard duty alert as the catalyst. So from there we have Cloud Watch rules, which take out, strip out everything except those ASN, unusable ASN caller events. We have a Lambda function that then checks against the DynamoDB and says, is this normal? So you have the first wave of detection, which is from guard duty saying, is it normal to access this resource from this particular network? And then we're adding a second layer on top of it, which says, and is this a normal action for this user account? Is it anomalous? The third layer we add on it is intelligence enrichment. So we have our deep site data feeds where we're able to say, are any of the IPs or other indicators in these guard duty events known to be associated with malicious attack actors? Obviously, if these three security components add up, you have a serious issue. So in that sense, we use all three components. We'll alert on it, but we can sort of dynamically prioritize based on a weighting between the three. And obviously then, it could be sent as findings to your SIM or Splunk or one of our service offerings. So this is actually kind of simple. Outside of the Lambda functions that we wrote, which are Python scripts that I can share, these are off-the-shelf AWS components. I took to two guys on my team about a week, and they got some really interesting results out of it. So first, they were using open source JavaScript library, D3.js, to kind of provide a visualization. This is a snippet of it, of what the normal user account access was like. And I think it really hits home to expect that a SOC analyst can look at something like that and say, oh yeah, that one's the problem. So guard duty does a good job at that for us, right? So guard duty helps narrow it down and say, hey, this user action is happening from a network or an IP that it doesn't normally happen from. So the enrichment process that I described after that takes the next level. And so again, with D3.js, we sort of visualized, what are the specific actions that user was taking? And then based on our threat intelligence and the signatures that we put into that DynamoDB instance, we categorize, which of these actions were benign or potentially malicious. And we don't have time for me to go through the entire story, but within minutes of the team putting this system up, we found what is essentially Bitcoin mining. If you follow through that story that is illustrated there. Somebody got into the system, figured out what role they have, created a different user account, and then use it to ultimately spin up a bunch of cryptocurrency mining. So the final leg for my time with you is really to then describe the importance of being able to take the outcome or the output of things like that and then make sure that it's managed along with all of the other security detections you have, because prioritizing things is much easier when you have them in one place, right? So that you're not wasting time looking in different consoles. So we have been working with AWS on their new security offering, the AWS Security Hub. This was announced this morning by Andy in the keynote stage, so hopefully you saw that. I'm not going to go into too much detail on it because I think my colleagues are going to spend some of their time going through it, but it's very interesting. I would recommend you take a look. There's a lot of promise based on what we've seen in our MSS offering and being able to put findings into this. So definitely take a look. So with that, let's transition over. Thank you, guys.
Thanks, Clint. My name is Rich Forwaller. I'm a product manager here for Symantec. My focus is on a product that we have specifically built for security in AWS. We call it Cloud Workload Protection, or CWP. I'm not going to focus too much on the product. I'm more going to talk about how we use AWS services to create a better security offering. But I do encourage you guys to stop by the booth if you're interested for the demo. The main reason I do that is we actually keep a tally of how many people we send to the booth, and if I win, I get like an Amazon gift card. And I'm not ashamed to admit that I get all my swag at these conferences for Christmas gifts for my kids. So it's terrible, I know, but it's the only way that I can scale as a father. That's how I kind of put it. So I do encourage you to come by the booth. We'd love to give you a demo. But again, I'm going to talk about like what we use in AWS to create a better security product. So the areas that I'm going to focus on, I hope I'm pushing the buttons here, right? Beautiful. The areas I'm going to focus on are the conversations that we had with our customers that kind of drove us to make this product. And then I'm going to talk about challenges that our customers had using our product in AWS and how we started using more AWS services to overcome those products. Then I'm going to turn the last part over to my colleague here, Scott. We've been working with the team at LifeLock to kind of have a better integration story with the AWS security services. And I've been bugging them for probably too long. I don't know if he's going to call me a colleague anymore. I may be an ex-colleague. But we're going to talk about some of the testing cases that we did with the AWS Security Hub and how we tested a scenario where we came up in a way that we could kind of reduce some of the noise that you can get with some of the AWS security findings and really kind of focus your efforts on what we think were most important. So just kind of a background. So Symantec, we're a traditional security vendor. We have a lot of our customers that have purchased our products and they're moving to the cloud. So a lot of the conversations we have, to be honest, is just how do I take what I have today and how do I move that to the cloud? And it's perfectly understandable. You've maybe got processes, you've maybe got things that you understand, you're used to the products, and they're literally just looking for a lift and shift kind of approach. Although we would never kind of stop our customers from using our products in AWS, and many of our on-prem solutions do work in AWS, we think that's the wrong approach. And the reason we think that is the wrong approach is you're moving to the cloud because of either cost efficiencies or, like in Clint's case, you're getting more efficiency, you can scale more. There's all these benefits. There's no reason why those benefits shouldn't evolve with you in a security perspective as well. So I'm sure you've all heard about, the cloud journey and things of that nature. We kind of call this, and I worked on this animation for 3 weeks, so bear with me. Yes, security evolution to the cloud. So we think that your security should be better. We think you should be more secure, and we think you should take advantage of things that are built into AWS to make a better security solution. And that is the kind of mantra that we have had as well. So here's a couple of the scenarios that we have. I'm going to dive into kind of 3 specific problems that we solved and how we did this with AWS. The first one was I tried to be as PC as possible and said, am I following AWS best practices? But really these conversations with customers are, we don't know what we're using in AWS. Like, we don't know what teams have access. We don't know who has accounts. We don't know what they're spinning up. So I need a very fast method to understand how I'm using AWS. And I don't want to stop them from doing that, but I've got to have some good visibility into what they're using into AWS. The second one is how do I deploy your solution a lot faster, a lot easier? So we've got a couple of different components in our solution, but one of them is an agent-based security. And so it's an agent that you deploy in your EC2 instance. It does things like file integrity monitoring, OS hardening applications. It's really hard to get agents on your EC2 instances. And it's not so much that you don't have that capability of it, it's because things are spinning up so dynamically that you've got this really short window on what you can do. But really what we find, and I find this fascinating, is I find security teams that have been given the responsibility to secure AWS, but not the empowerment. And so a lot of the conversations we have is like, we're supporting these BUs, and we're working with these different teams, but I can't go back and interrupt their development to say you need to install an agent. Like that has to be the first step you do. And it's not like in an on-prem environment where that server was coming to the IT lab first and they were imaging it and then handing it over to the developer team. I mean, these developers they're in the console themselves spinning it up. So it's really about how do we create a method, or are there even use cases that we can give them security without doing this agent? And that's kind of where we kind of looked at it. And then the last one is where I'm going to turn it over to Scott, where how do we leverage the native AWS security services? So today, the Security Hub was announced. There's Inspector, there's Macie, there's Guard Duty, there's all these rich things that AWS does. And some of them, just to be honest, some of them do have crossover overlap in what we do, but there's no reason why we can't just say, let AWS fix that problem, and we can build on top of that. Just like when you are moving your workload and over to AWS, let them deal with the hardware problems, let them deal with the scale, whatever that scenario may be. We look at security and say, let them deal with it and let us kind of build on top of that. So let me walk through the first one, building visibility. I love this. And to me, this is just the power of APIs, to be honest. This is just the power of APIs. So the first question we always get from our customers is, how do I know what I'm doing? How do I know what I spin up? So the way our solution works is our first kind of onboarding step is we have a CloudFormation template, really, really simple. You go into that CloudFormation template, you fill out a couple of pieces of information. We then use that information to create a cross-account IAM role. We use that cross-account IAM role to query the services. So depending on what you select, we're looking at like EC2, we're doing describe instances and things like that. But we can expand on that. We look at VPCs, we look at route tables, we look at the services. But to be honest, within about 5 or 10 minutes, we have a pretty good understanding of what services you're using, what regions you're deploying, what types of EC2 instances you're spinning up, what are the OSs on those, all that rich metadata that comes from the APIs. Our second kind of phase that we do is we track our changes, and this is just, again, a no-brainer. We just use CloudTrail for this. So as part of this onboarding process, we'll spin up CloudTrail for you. We're writing those logs to an S3 bucket. Again, nothing really special here. And then we're just setting up an SNS topic and an SQS so that we know, hey, when a new log gets delivered to S3, we should know about it, kick off a process so we can read that, and then we'll go in and say, oh, yep, they've killed this EC2 instance, they've spun up a new one, or they've no longer using this service, here's a new one, and just to kind of track those changes. So literally within like 10 to 15 minutes, we have a very good understanding of how you're using AWS. Now that might not seem phenomenal in the sense of, well, yeah, anybody can do that, but take a step back and say, what on-prem solution could do that? Within 10 to 15 minutes, where in an on-prem world could you run a script and say, show me all the servers I'm using, show me in what the data centers they are, show me which ones have protections, show me where I'm following best practices and where I'm not following best practices, benchmark me against the AWS Foundations benchmark or whatever equivalent CIS you're looking at. I mean, that would just, whoever could do that, I want to work for that person because they're making a lot of money. It's just an impossible solution to sell. But the richness of the APIs makes this really, really easy for us. So to us, this was a no-brainer. We should just be absorbing this information. We should just be presenting it to our customers and giving them a nice, quick, easy way to get, okay, I've got a nice baseline of visibility into AWS and I can look at the changes that I'm going. So that's kind of one scenario that we look at. The second one we do is our agent deployment. So we do have a lot of customers that, again, they say, we just can't deploy your agent. I've got BUs that I'm handling. I can't do them to me. Or what we run into as well is I can't interrupt that CI/CD pipeline. Like I can't interrupt that application development to go and install this. So this is a hard challenge for us to solve. And I wouldn't be honest to say we haven't solved it 100%. We still fight these issues. A lot of our more I would say polished or advanced customers, what they're doing is just like taking our agent and baking it into the AMI, and they have like a library of AMIs that they can use, and that's how they do it. But we do have customers that are still kind of evolving into that, and so we literally get requests saying, I would just like a button that I could push and it could deploy. And so we looked at that and said, well, that's got to be possible, right? There's got to be a way to do that. So what we did was we started working with the AWS Systems Manager team. So if you guys have played with this, this is like one of my favorite services in AWS. It's a compilation of, I want to say, like 11 services. They just announced one 2 weeks ago called Distributor. But basically what it is, it's a system that allows you to do kind of orchestration level or automation things across your AWS fleet. So you can do things like patch management, you can do inventory, our favorite is the run command, and I'll walk through what you do with that. But the nice thing about this is you can actually use it outside of AWS. So the kind of a core piece that they use is called the Ssf Agent. And that is an open source agent that AWS has out there. But the great thing that they do with this is they bake this in to the kind of the more popular AMIs. So it's in all the Amazon Linux AMIs, it's in all the Windows AMIs. I believe it's all in the Ubuntu. The one big one that we do miss out on is Red Hat. That one is a little bit of a problem for us, but it has a pretty good covering of what that is. So that means every time you're spinning up an image from one of those Amazon Machine Images or AMIs, that's already baked in. So we looked at that, we're like, well, duh, it's already in it. Why aren't we just utilizing this to install our agent? So that's exactly what we did. So the way we do it, again, it's the same CloudFormation template that we have to our customers to sign up. Again, we're spinning up a cross-account IAM role. We do a little bit of a different tweak on this. We do have a Lambda function just to kind of give us a status check of how that creation is going. And then what we do is, again, just through the APIs, we're querying all the EC2 instances. So what we'll do in this step is we'll actually come back to you in our product and we'll say, hey, these are all the EC2 instances that we have found, and we query those to say which ones already have the SSM agent installed. We'll then come back to you with a list of those, and basically we'll just ask you, would you like to install our agent using the SSM agent? What our solution then does is it takes we call it the CWP agent, we put it into an S3 bucket into the customer's account. We then issue the run command. So this is basically a run command that you can issue out to the agents to perform certain actions. So essentially what we're telling the SSM agents is, hey, go to the S3 bucket, download the agent, and then just go ahead and install that. So we'll issue that to SSM. We do upload some logs just for more troubleshooting and diagnostic purposes and things like that. We'll deploy that against those instances. You can actually, we've got some built-in security policies that you can take as well, and you can push those. And then we do another Lambda function. We're actually going to clean this up a little bit and use the state manager in SSM to make it a little bit more clean. But we'll do another Lambda function with an SNS topic. That just tells us how the status is with the installation. So you'll see within the product, you'll say, hey, we discovered 100 instances, 95 of those have SSM. We're going to install it into others, and we just kind of tick away at those and show you what the progress is. This has been, to be honest, this has been phenomenal for our customers who are very new to AWS, who are saying, I'm just looking for a nice, simple way to deploy this. And this gives them a great inventory of their EC2 instances. But again, if you step back, if you pretend you weren't in AWS and you say, how could I have done that in the on-prem world? It would have been a very, very hard challenge. You would have probably had to stood up like some deployment server and maybe, I don't know, integrated it with your domain controller and run scripts or things like this. But within a customer's environment, within 10 minutes, with this cross-account role, we query EC2, we discover all your assets, we say which ones can we install the agent. Again, within 10 to 15 minutes, you've got security in that. So these are just, we look at these things and we're just like, this is phenomenal, this is awesome. We can provide our customers with better security by just using these services. And that's really how we kind of look at the world of AWS. I'm going to turn it over now to Scott. So to give you a little bit of background, so we've been working with Scott, and we've got Corey here as well. So if you guys have any questions, and if they're really hard questions, I'm going to give them to them. But we've been working for them for a while, really around kind of a guard duty use case on how can we complement what guard duty does. And so I'll turn it over to him, and then we'll do some Q&A towards the end.
Great. Thanks, Rich. Good evening. My name is Scott Webster. I'm a senior manager with the information security team at LifeLock. And so we were contacted, as Rich mentioned, to put this together. And it's been an interesting little journey. So essentially, Corey and I worked on creating one simple which we looked at brute force login attempts. So let me forward this through here. That were reported by guard duty. So the concept is, and these are extremely simplified, right? Many steps removed. But essentially, guard duty would produce, hey, we see a brute force attempt on maybe an SSH port that's open. That's interesting. Brute force is one of those ones that you're never quite sure if they got in or not. And so you kind of want to take a look at that host and understand what's going on. But we also want to make sure that we're not wasting a lot of time. Now, one thing to keep in mind here is that there's many ways to investigate this, and this is just a demonstration, so very simplified. And any finding you get from guard duty or any threat intelligence tool or threat detection tool, you want to make sure that you're validating that against multiple sources. You're not just taking that as this is truth, and therefore I need to go do something about it. We also want to take a step back and say, well, what would be an appropriate action if we did want to automate this? I see brute force happening. What's the appropriate action? Should I just shut the instance down? Probably not. So we want to take more of a benign action that provides context back to my analysts, but doesn't necessarily impose any harm in the production environment. So, yeah, and we basically just want to make sure we're not wasting valuable time. So in this walkthrough, essentially you have CloudTrail logs and flow logs coming into guard duty. It's figuring out it has a detection for brute force in this particular case. That finding is going to come into log aggregation. It's also going to go into, so now my analysts are basically looking at that in the SIM. And they're saying, okay, great, I've got a brute force attempt. What do I do now? Great, so let me log into CWP, and as one of their things within their playbook, they would kick off a scan to do basically a malware scan on that box. Is there anything that's been installed recently? What was going on? Just additional context. We want to have context when we're doing investigations. They've got to go into CWP, they've got to log in, kick off the scan, wait for the results, and work their way back through that investigation, and they're just going to continue circling around until they've got enough context and understanding, and then they're going to close it out. So how do we simplify that? That's some extra steps and extra time, so that's where we're going. So now, since Security Hub has been introduced, essentially we can streamline some of this. So we still have the same finding, right? Guard duty produces the brute force finding. But now that finding goes into Security Hub. And in parallel is going into CloudWatch, and there's a function in Lambda that is reading those CloudWatch events and producing, basically kicking off a host scan. So just cutting out one of those steps for what we need to do. And so then the results of that scan, in this particular case, and I'll show you in the next slide, that the finding, there was some malware found. So and that provides my analysts more context, basically, to say, okay, there's definitely something going on here. There might be tons of other sources of information that you would use to understand that attempt, and certainly not the only, but this is very helpful. So here's essentially within the beta of the Security Hub, you can see we've got the Symantec Cloud Workload Protection, Anti-Malware Threat Detection, and then if you would click on that, you would basically dig into the result and understand, what was found and how it, plays into what the next steps are for my analysts. Again, anything we can do to eliminate steps, automation is the big deal for now for security operations centers. Let's automate, let's streamline these work flows. So anything we can do to streamline. So hopefully this has been helpful. I would definitely say, we want to make sure that you can move on to the next, take your analyst and move them on to the next thing, right? We don't want them dwelling in a particular incident too long unnecessarily. So the sooner they can get more context, the better. And with that, I'll turn it back to Rich. Thank you very much.
Thank you. Thank you very much. Oh. He gets an applause, and I accept.
They're happy it's over.
That's probably what it was. Cool. So again, if you guys have more questions, please come by and visit the booth. Just for kind of a precedent, so the Security Hub, as you mentioned, or as Clint mentioned, it was announced in preview today, so we're actually in that console. We do have a free trial as well, so if you want to go ahead and try that. The steps that we do to integration are pretty simple. We adjust a little bit the IAM role so that we can write to those. And then this Lambda function that we kind of mentioned to here, that will be actually available in our GitHub repository. It's going to take us like a day or two to get it up just because we've got to go through some processes to get it up or whatnot. So if you guys want to play with this, you're more than welcome to do it. The way we did this is we're just looking for those 2 findings that Scott mentioned. So if you see the brute force and the port scan, what it will do is we've got a Python script that's in a Lambda function. It'll kick off that CWP anti-malware scan, run it through the EC2 instances that are affected, and then post those results. But we're really, to be honest, we're really looking for some feedback on this. So if you guys have some other things or other kind of functionality or data that you would like us to see pump into the Security Hub, again, come visit us at the booth. Please tell them that Rich sent you. I appreciate the gift. We'd love to hear from you guys. So I think we got like 4 minutes left. So I don't know if there's any other questions or we're good to go. Yes, please. So the question is, if we've got a team that doesn't have access to their AMIs, does our automation do that? So as long as the AWS account that we have associated with the IAM role has access to that, we can go ahead and push those out. So what I have seen customers do is they do have BUs that they say, we don't want you doing things, but we will dictate to what you do. So the more sophisticated ones, to be honest, they've already gone in and just put in a boot up saying always have the agent in there, and then they've given like a library of AMIs that they can do that. But as long as that account has access to it and you've confined that account to a team that you are okay giving permission to, we can do that. Yeah. Does that answer your question? Okay. Yes, please. So the question is, do we have any automation looking at web requests and identifying kind of, would it be like, I don't know, like bad IP addresses, like reputation lists? Is that what you're thinking? So my product per se does not. So what my product will do, CWP, it actually looks at the files that are being accessed. And it will say whether this is allowed or whatnot. Now part of that is we do take a threat feed from some of our other services. So if there are some bad actors, we'll have that in there. But however, we do have other products that do that. And I can give you a view of those, and they are available in the marketplace. But if you're looking for like almost sounds like a WAF or something, is that kind of what you're looking? Yeah, we have other products that do that. That's not built into mine, so I can, if you want to come by the booth and mention my name again, or we can talk offsite, I can tell you the products that we have that do that.
From a services standpoint, we consume proxy data. And it's just part of the analytics modules we have. We sort of regex them against all of our security intelligence feeds. So I think, from a service standpoint, we can help with that use case as well.
Yeah. Cool. Any other questions? All right. Thank you very much for attending. Have a good conference, and we'll see you around.